you all for being here today. Welcome to the Data Science Speaker Series at the University of San Francisco. To those of you who are guests, it is nice to see you. Thank you so much for coming today. This is a speaker series that is sponsored by the Data Institute. The Data Institute is the umbrella organization for all data science and data engineering programming and research that happens here at the university. So again, thank you so much for coming. We're really excited to have our guest here today. So please join me in welcoming back Eloi Pereira. He is the head of data science at CarIQ. Today, he'll be sharing how his background in robotics and aviation maintenance informs his work, building scalable, data-driven platforms that power secure vehicle-based payments. So we're really excited to have Eloi back for a variety of reasons. As many of you know, he is also one of our practicum partners, which means that today, this talk is going to end promptly at 1:30 because Eloi has a few appointments immediately following with 4 individuals that were contacted yesterday. If you have any questions, you can let me know. Otherwise, I'm going to turn it over to you.
Hey everyone. Yeah, thank you a lot for the introduction, and thanks again for having me at USF. It's a pleasure to be back. I was here last year, and we worked with 2 of your former colleagues. It was a great experience. It's also great for me to be back in the classroom. I spent a good amount of my career, pretty much most of my career, either on your side or on this side of academia, either learning or teaching. So it's always a pleasure to be among students. It's also a great opportunity for me to remember those days. So this is where you can find me online and also offline. Online you have my contacts there. Offline I love to be outdoors. This country is a great one to do that kind of things, and now I have a little one that helps me doing that, which has been quite an exciting year regarding that. A little bit of what we do. Our marketing team made a little video to explain what CarIQ does so that I didn't have to. So grateful for them. Let's see if this plays.
Fleets. Every day, on every road, they keep business moving. So when it comes to one of your most important assets, don't let outdated payment methods cost you money and slow you down. Skimmed, lost, and misused cards, along with a high driver turnover, makes fuel cards a financial and operational nightmare. So get rid of your fleet cards and let your vehicles pay for fuel, tolls, and other expenses. With CarIQ, you can cut cards, cut costs, cut fraud, and simplify your business all in real time. Eliminate the time spent reconciling all those receipts, card statements, and latent data. By automatically tying expenses to vehicles, you can now accurately validate each transaction and track your overall spend. Now in one comprehensive dashboard, you can identify misuse, manage merchants and set spending controls, view receipts instantly, and issue immediate payment credentials for each vehicle. Nothing will save your fleet more time and money than by switching from fuel cards to CarIQ. Get rid of the cards. Get into the future of fleet payments. Learn more at cariqpay.com.
All right, so this is CarIQ. In a nutshell, what we do is, so if you have a fleet of vehicles, usually at the hundreds or even thousands of vehicles, one of the big hassles to manage those vehicles is to basically provide means for the drivers to pay for the services of the vehicle. The main one is fuel. So you're going to hear a lot about fuel today, but we also support other services like parking, tolling. Soon we're also going to support maintenance, insurance. So basically every service that a car needs, we basically streamline and automate the payments for those vehicles. In particular, when you need to hand credit cards to your drivers, that's when things get very complicated. Driver turnover is very high on this kind of fleet, so drivers come and go, sometimes even seasonally, just during the summer, for example. And just managing that is extremely painful. There's also a byproduct of handing credit cards to drivers, which is what we call misuse. So they might use them for their own private needs instead of for the company needs. And that's also something that you're going to hear a lot today. So how do we achieve that? So basically the drivers do not have a credit card. How do they pay for their services? Well, we sit between the merchant and the bank and automate everything, automate the overall payment, so that the only thing that the driver touches is an app. And an app, again, not even just like Apple Pay or Google Pay, where you actually need a card on file. There's no card whatsoever. We basically streamline everything. So the driver cannot pay for anything else other than the service that we automate support. So in the center, at the core of our network, sits the machine identity and intelligence platform, which is the part of the platform that I own, and that's the part that I'm going to talk today. The platform itself is way wider than these, and way more complex. There's a lot of complexities on other areas, but I'm going to focus on that particular part of the system.
Eloi?
Yes.
You hold the mic close.
Okay. Yeah, sorry. Okay, so how does this work? And again, using fuel as an example. So before the transaction even starts, we ingest vehicle data. So we are connected to the vehicles, and we ingest vehicle data 24/7. When we're talking about vehicle data, we're talking about location, odometer, fuel level, and any other engine temperature, tire pressure, everything that the vehicle sends us, we will ingest it. And first thing that we do before a transaction even starts is to authenticate the vehicle. So basically understanding if this vehicle is what it's supposed to be, so avoiding any spoofing. The other step is what service it needs. So, for instance, if this vehicle, if the tank capacity, if the tank level of this vehicle is full, then obviously it doesn't need fuel. So we would say, well, if you want to fuel up, then you have $0 that you can, because there's no need for fuel. So we take the state of the vehicle, we estimate the state of the vehicle, and regarding that, we decide what services it needs. Then we do the merchant selection. So are there any merchants that can provide this service around? So in this particular case, are there fuel stations around? Are there preferred fuel stations that the fleet manager prefers the drivers to go to? Or even if there is any heuristic behind that they want to be enforced. So for example, if they want the drivers to only go to the cheapest stations around. So we also take care of that. And then after all of that is done, then we actually do the funds allocation. And during the funds allocation, what happens is each vehicle has its own bank account, little bank account that it's usually at $0 most of the time. Right before the transaction, we load the vehicle with the funds that are necessary to perform the service. So again, for a fuel transaction, if we see that the tank needs 10 gallons worth of regular fuel, and the price per gallon is $4 per gallon, then we load, let's say, 40 bucks plus a little wiggle room to just cope with some uncertainty. And then the vehicle goes to the next phase, which is the transaction and the service itself. So at this point, that's where we communicate with the merchant. We basically authenticate with the merchant, set limits with the merchant. Like, for example, the volume that we want to let the vehicle ingest. And then the driver performs the transaction. When the transaction ends, we generate a receipt. We send the receipt to the driver, like a few seconds after the transaction is settled. The driver receives the receipt. We detect if there's any anomalies or misuse, and these might take a little while because we need to wait for some data to come in. But as soon as we detect some misuse, we notify the fleet manager. For some cases of misuse, we even notify the driver. And this is because it creates a certain deterrence effect that I'm going to actually approach a little bit later. And after that, the fleet manager can also analyze all these data, all these transactions, and resurfaces up actionable insights so that they can act upon the data that we collect. Any questions about the process? Okay. So how fraud looks like. So again, like I said in the beginning, I'm going to talk a lot about fraud. Oh, by the way, one thing that I forgot to say. I'm going to divide more or less the presentation into two. The first one, I'm going to describe what we do. And then the second part is more of lessons learned that at least myself collected during the times that I've been in car IT developing these systems. And that part I intend to be more of a lecture than a talk. So please ask questions, and we can skip some topics. We can go deeper into others whenever you feel like it. So just FYI. But also during this part of the presentation, just interrupt me whenever you want. So this is how fraud looks like for fuel transactions. So the plot that you can see at the top right-hand side is the fuel level that we ingested from a vehicle. The blue line that you kind of see it behind that orange bar is the raw data, and as you can see, it's kind of noisy. And that noise has a lot of reasons to exist. Some of them is actually just the physics of things. There's sloshing inside the tank, and that kind of makes the sensor that you have inside the vehicle is basically a floater. So it's impacted by that. But also there's other kinds of noise. There's like known unknowns and unknown unknowns. So we need to cope with all of them. So in this particular case, we see that at the time of the transaction, the tank was more or less at half. And after the transaction, there was no ramp up, right? So the fuel didn't go up, meaning the fuel didn't go to this vehicle. So at this time, what we do, we compile all this information and send it to the fleet manager. Not only the information about fueling, but also to create context, also the location, the route of the vehicle going towards the station and leaving the station is usually insightful information for the fleet manager, because they might just realize from that that they are not like at the job site, for example, they're like at home. That's the kind of information that you don't really have. But the fleet manager has, so we provide it so that they can act upon it. And obviously what you are seeing here is what I see as a data science and my colleagues. But obviously this is surfaced up as a nice UI to the fleet manager. The fleet manager doesn't need to know YAML to interpret this data. Even though, I mean, YAML is quite big. Right, so usually fraud never comes along. Yeah.
So when the driver goes to the gas station and the car gets authorized to the amount, after the amount is authorized, they can do whatever they have.
No. So at that point, as soon as the funds are allocated to the vehicle, the transaction, who handles the transaction is still us, between us and the merchant, right? So again, there's no credit card. So at that point, the funds are allocated. But then the next step is to talk to we talk to the merchant, quote unquote, and say, you can let this vehicle transact for X amount of dollars. So that's it. That's what it can happen. The only thing that the driver does not touch the funds. That's the fundamental difference between us and giving a credit card to the driver. What the driver could still do, and the case that you're seeing here is, let's say you take, there's actually two typical cases where we see what we call credit fraud. One we call the jerry can scenario, which is you take a jerry can with you inside your company's vehicle, and you fill up your company's vehicle and put some on the jerry can. The other case is what we call tailgating, which is you go to the station with your company's vehicle, but also with your private vehicle, and you fill up your private vehicle instead of the company's. But that's why the location of the vehicle, as you can see, is very important, because that's actually the first step that we do. If the vehicle is not at the station, we are not going to let it inside. Good question. So what you're seeing here is the behavior of a given vehicle. All those little bars are fuel transactions. The light blue is the state of the tank before the transaction started. The dark blue is the estimated volume that we estimated that went inside the vehicle. And the pink part is fuel. So the transaction was X amount, and we only saw ingested one. So that's where what we call where misuse happened. And in this particular case, the misuse on this particular vehicle only started happening when one specific driver started driving. So that's when you start seeing the pink appear. We start surfacing up this information to the fleet manager. Eventually, the fleet manager contacted us to kind of give a little bit more context, because whenever they want to act upon this information, they want to be absolutely certain that what they're seeing is actual misuse. Then the driver got in trouble, and after that, his misuse at the very least went to see. So it's not taken. Go ahead.
Is that the only context where you can get like some sense of truth or labeling, like a prediction model?
I'm going to go through that a little bit later. So in this particular case, all the modeling that's happening here is non-learned. What I say by this is, since these are behaviors that are easy to model, we model them manually. So using system dynamics, basically. So which is also kind of a lesson learned that I had there that I removed, that I think I spoke about it last time that I was here, which is if you know the dynamics of your system, don't use machine learning, just model it. In this particular case, it's very simple. The vehicle drives. When it drives, it consumes fuel, so fuel goes down. At which rate? Well, based on the system dynamics, which can be a little bit complicated sometimes to model, but it also all depends upon the accuracy that you want to achieve at the end. We do use machine learning for and predictive analysis for another service that I'm going to talk about later. So, yeah, any further questions?
Is the main focus area only on fuel, or like any other related expenses during travel like that?
All expenses are of interest for now, for us. We do support fuel, parking, and tolling right now. I would say fuel is by far our major source of revenue. Next, tolling, and parking is usually sits on the third. We want to start supporting also maintenance, which is also a big chunk. It doesn't happen a lot, but when it happens, it's a big one. So we want to cover that as well.
Thanks.
So when you say like you load or load the amount to some pallet or something, like is it like you have a credit line which you
Absolutely, yeah, good question. So, like I said, each vehicle has its own little account. It's usually very thin. But the fleet itself has a big account, what we call the primary account. So the funds go from the primary account to the secondary account, and then after, which is a step that I didn't mention there, after the transaction is settled, the remaining money that sits on the primary account goes back to the secondary account goes back to the primary account, and it is based on the credit line that we offer. So we have a credit service.
and the settlements happen
So how exactly are you getting this sensory data? Do like the fleets, do they register their vehicles somehow on your platform? How exactly does that work?
Also a good question. Most of these fleets, whenever they have, at least not like small fleets, but like large fleets, like I would say above 50 vehicles, they usually have what is called a telematics device. Because they want, the fleet managers want to know what their drivers are doing and also how they are behaving, like if they're speeding, for example. So, so there's these little dongles that you connect to the vehicle and sends data to the telematics provider. So one of the big things that we need to do that is kind of unique for CarIQ compared with other telematics providers is we need to create ingesters for these telematics providers. And we try to make to be agnostic, meaning we support as many as we can physically can, given our engineering, the size of our engineering team. So the major ones that we support are Geotab, Samsara, which they sit like quite close to us actually, Zuga, InTouch, all of these, and so we need to create these ingesters, normalize all this data, and store it so that we can then true users. But it is definitely a big chunk of the data-intensive part of this application that is running under the hood. All right, so going back here to our fraud analysis. So, so in this particular case, as I said, the driver stopped performing fraud. The interesting fact is that deterrence was spread not only for that driver, but also around the fleet. So what we saw is this is the misuse that happened on that fleet before, during, and after this event happened. There was other, even though on that specific vehicle that I showed you, there was no misuse, but on other vehicles there was misuse happening. As soon as this event happened, the fleet manager acted upon this information, then the misuse went to zero. Granted that there is some seasonality on this, meaning because of the driver's turnover, eventually it starts appearing again, and then the fleet manager acts, and then it goes back to zero again. So it's a little bit of there's a bit of a dynamic there, but you can see that deterrence effect happening whenever the fleet manager acts upon the information that we provide.
Yes. How does the cost of this control activity stack up against the benefit?
Say again, sorry.
How does the cost of this control activity for the fleet managers stack up against the benefit that they're getting?
That's a good question. We have what we call the platform fee that we negotiate. It's not a fixed value. We negotiate with the client. It depends on the size of the client. So there is indeed a cost per vehicle per month that the fleet manager incurs by using us. So there is a little cost per vehicle. Now, the benefit of that compared with fraud, I think it definitely compensates. Just because the deterrence effect doesn't happen just because of the like when a fraud actually happens. The deterrence effect of us existing just for removing the credit card from the driver and saying, hey, you are not using this plastic any longer. You need to use this app on your phone. By the way, you can see that there's we can see where you are and you can see what you purchase. All that deterrence effect removes, I would say, the majority, and this is conjectural because I can't really measure it very well, because I don't know the before very well. The before CarIQ, I can only know after. But that deterrence effect, I would say, just removes a lot of fraud. So I would say just out of the door, just by signing with us, you gain that effect, and then you're also able to identify bad apples, and again remove it not just for that, remove the fraud not just for that driver in specific, but also for other drivers. So I would say that definitely the platform fee compensates the eventual fraud that these drivers will be committing. But it is a case by case again. I mean, if there's some fleets that might have their, like for example, if the fleet is small enough and it's like a family business, maybe you trust your family and this doesn't make much sense for them, right? So it really depends upon the trust that you have on your drivers, and the bigger the fleets are, I think the more the higher is the risk. Thank you. Okay, so about transaction prediction, and that's where actually we use machine learning, and that's where your colleagues also worked on the last year on their project. So we realized that, okay, we're collecting all this data, we're collecting all this vehicle data, we're collecting all this transaction data. We have a aha moment where like said, well, we can probably use this for other than just like operationally detecting fraud. We know where the vehicle is transacting, for how much. Why don't we predict where and when and for how much a vehicle is likely to transact, and offer that service to our merchants? So let me give you an example. If we know that a given vehicle is likely to transact at the 7-Eleven, for example, this is usually the example I give, because 7-Eleven has a convenience store. Why don't we tell Circle K, which is one of our partners, hey, why don't you give a coffee on the house to this driver and try to capture that transaction to Circle K. So this is a new product that we've been developing, and this one is fully based on machine learning, because we are trying to, and that's why system dynamics doesn't really work here, because we are trying to model something that is very non-linear, which is human behavior, right? So that's the kind of thing that, at least that's my rule of thought as an engineer. Am I really, what I'm modeling, is it really, is it quite non-linear? Is the uncertainty very high? Well, if yes, then I might prefer to use machine learning. Otherwise, I might just try to model it myself. Because by modeling it yourself, you have a better observability of what you're doing. Might take a little while, but it compensates in terms of accuracy. So this is an example of the use of that, of the prediction analytics. So those the red dots that you can see is vehicles that we sampled that are, we claim that they're unlikely to transact. And the green one is the green ones, are the vehicles that are likely to transact, and the little station symbol is the target station. That's where likely they're going to transact. And so that's the information that we can surface up and act upon. On the right-hand side, you see some of the features that we evaluate, and that's under the hood, that's what's part of the model, which, for example, is the tank level, obviously. It's the one that most likely is going to correlate the best with the target variable, but also the hour of the day of the week, the merchant itself, and many others. Go ahead.
What do you do when you lose connection with the vehicle for a while? Like, it wouldn't be close to where the station is.
Yeah, that's a good question. And it relates to another question that your colleague said. I'm going to go through that a little bit later. Okay, any questions about likelihood to transact? And by the way, this is still the area that we are productizing, and that's where the project that we proposed is sort of it's basically picking up from what your colleagues did and what I've been working on as well, and taking it to the product level. Basically, that's our next phase. We already have a good proof of concept. Now we want to productize it. So basically, all the way into it. Okay, so this kind of finishes up the first part of the presentation. So now I'm going to talk a little bit about my lessons learned on building these kind of systems, and I didn't forget the questions that you posed. They will be part of this part as well. But any questions for the first part?
You want to collect this data and the stations like this. What is your methods for collecting data? Eloi or just stations?
Yeah, so the vehicles are connected through these telematics providers, so these little dongles that the car, the fleet managers buy, and they connect to their vehicles. And the majority of those are by a 5G or 4G, sort of like cell phones, but little, like compact as a little dongle. But yeah, they usually are like they go through the cellular network. And all that data first goes, it doesn't go directly to us, it first goes to the telematics provider cloud, and then we connect through, and depends on the telematics provider, but we might connect through APIs or through webhooks or whatever technology they support. We connect to them, and that's where we ingest all this data to our site. We do have also projects of connecting directly to the vehicle to try to remove this all. Because the majority of vehicles nowadays, OEMs already provide vehicles that are connected. So they usually are very conservative at opening up that door, but we are also exploring that so that we can connect directly to the vehicle and not having this middleman in between, which for me specifically would be great because I will get better data with more accuracy, so I'll trust more the data. And a lot of the uncertainty that I need to work on to remove, it wouldn't be there, so it would be a good thing to do. But those days are still a little bit more like mid to long term.
Hi, my name is Lynn. Thanks so much for coming. I have a question. So you were saying that you're using these you're trying to build a predictive model for transactions to help merchants. I was also wondering, do you share this data with the fleet, or have you thought about selling it to the fleet for them to help better forecast their cost of services?
Yeah, absolutely, yes. And I would say, again, this is still being under development, but I would say the fleet would be our first GDP for this service, because knowing that the vehicle is likely to transact is also interesting from an operational standpoint. Also, if a vehicle is unlikely to transact, and by the way, it transacted, then it goes back to my fraud part, which is, okay, well, for that specific fleet that you saw those features, you might have seen that there was no transactions supposed to happen on the weekend. So if a transaction happens during the weekend, then we will label it as unlikely to transact, and the fleet manager could act upon that. By the way, this specific example, we already precluded because the fleet manager can actually define which days of the week the vehicle can transact, but we do have some vehicles that transact all over. They don't have any restrictions because they do have services during the weekend. But if we detect that it's during the weekend at 1 a.m., maybe that's actually an anomaly, right? So we can definitely use it as an anomaly detector, but we can also use it, to your point, to forecast the cost more like, midterm. What do I need in terms of funds for next month, for example? Some of our businesses, we have one that is a major pool maintenance company across the US, and they have a strong seasonality, as you might imagine. There's more business during the summer, we'll call it pool season, than during the winter. So we can definitely forecast the cost and see that and model that seasonality, and if there's any trend as well. Okay, so now shifting gears to the lessons learned, and I'm starting with this picture that comes from a book called Designing Data-Intensive Applications by Kaplan. It's one of the books that I definitely recommend if you're building large-scale data intensive applications. It's very detailed, but also has quite philosophical, I would say, aspects to it, if you can distill it. And it's actually a fun book to read, even though it's a technical book. By the way, there's also a great audiobook. Surprisingly enough, a technical book as an audiobook usually doesn't work very well. But anyway, so this book, or the author, claims that to build large-scale data-intensive applications, you need to focus on 3 big pillars: reliability, scalability, and maintainability. And I'm going to approach some of them. I could probably have do several lectures on all of these topics, so I'm not going to go in depth on a lot of it, but I'm going to at least list the topics that I think they are important on each category, and we can go deeper in any of them if you want, and if we have the time. So in terms of reliability, so what is the reliability? It's basically building trust. In this particular case in your data system, building trust on the data that you're providing, but also building trust in terms of the availability of the system. Is the system going to work? What is the SLA that you're providing to your client, right? So, for instance, for us, it's very critical that drivers don't get stuck at the gas station trying to fuel up and not being able to. This is where our customer success and customer support team focuses, I would say, 90% of their time. Because sometimes it's the driver's fault, sometimes it's our fault. I mean, we never know. So, but we spend a lot of time there because, again, reliability is a big part of the system. So, the first topic that I put there, and kind of goes between the dichotomy between failure and fault. Do you guys know the difference between a failure and a fault in this context? Well, I see some yeses. So basically, the failure is something that you want to definitely avoid, which is the system doesn't work. Right? So again, the driver is trying to go to the station and it's like trying to fuel up and he can't. That is a failure. A fault is a component or part of the service that you're providing failed, but you are still able to provide your service with some restrictions, with some degrade, maybe the performance degraded a little bit, but you're still able to provide your service. So the main lesson, or the first lesson I would say is always avoid failures at all costs and build systems that are fault tolerant. And I'll go to some examples on that, and I'll go back to some questions that your colleagues made. Other parts that I'm going to talk a little bit is about automatic recovery, self-healing, and also uncertainty. The 2 topics down there, the CAP theorem, basically the consistency, availability, and partition tolerance that you can have on these systems. I'm not going to approach today, but it's something I wanted to put there because it's quite it's fundamental and it's quite important as well. And data validation, it's pretty obvious. So about fault tolerance. So again, failure, we need to avoid it. There's nothing we can do. Let's go all in and try to avoid it as much as we can. One of the ways that we actually avoid failures is to be fault tolerant, meaning whenever a system, whenever a component of my system is faulty, then I can recover from it. So this is the phrase that I usually use: is if you can't avoid crashing, just crash gracefully. And I put there a little image of 2 grapplers fighting, because I kind of see it as an analogy. If you've done any martial arts, specifically grappling, the first thing that you learn is how to fall. So sometimes you fall also strategically, specifically in jiu-jitsu. That's where the analogy ends. So you don't make your system false. Just strategically doesn't make much sense. But I mean, I see an analogy there. So how do you avoid? How do you crash gracefully? Well, make your components small and simple, and always find paths. If that component, always think, if that component fails, what happens next? Can I still perform can I still avoid the failure? So one of the places where we do this is precisely when we lose communication. Like I said, these telematics providers, we rely upon them to give us the data, and sometimes drivers driving to places where connectivity is very low, or they might even disconnect the device on purpose to try to go with trying to fake something and maybe commit some misuse. So we have what we call the offline mode, which triggers if a vehicle is trying to transact and there's no vehicle data available, that basically sets a set of rules that are quite strict, but we still let the vehicle transact. So after the transaction happens, we put a bigger emphasis on post-validation, meaning we are actually going to we're going to label this transaction as a transaction that happened on offline mode, and pay again more attention to fuel validation to see if, in this particular case, fuel, right? If the purchased amount was actually delivered to the vehicle. So this is one place where we have where this concept of crashing gracefully is pretty evident, but there's others throughout our platform. The other thing that I would suggest, and this one is a kind of a personal one as well. Before joining CarIQ, I was leading a team at the Portuguese Air Force that performed calibrations of equipment that were used basically to maintain all the aircrafts on our Portuguese Air Force. And one thing that I learned is to appreciate uncertainty, to measure it and to act upon it. So there is no such thing as 100% accuracy. Don't try to chase it. It's not going to happen. So you need to just embrace it. Uncertainty is there. But then you need to understand also what is the level that I can cope with this uncertainty. And if it is higher than a certain level, I need to do something. So make it part of your decision process. So one place where you might have seen it already, that I measure uncertainty is on when we're measuring fuel level. So again, like I said, the fuel level is, the raw data that we get is very noisy. We clean up as much as we can that noise, but again, the uncertainty is still going to be there. So we measure it. That's the orange band that you see around the orange line. And we make that part of the decision making. In this particular case, we always give the benefit of the doubt to the driver. So we're always going to use the uncertainty added to the value that we estimated to give the benefit of the doubt to the driver, because we want to reduce as much as we can false positives. Yes.
So you all this uncertainty and contrast, the model that you are creating at the end of the day.
Another part that is also kind of comes back to my days in academia. Actually, when I was in academia, I worked a lot in robotics, and this is part of control engineer. It's always on the mind of control engineer, which is finding feedback, which is what helps the system, what helps you to control the system, but also to make it robust towards disturbances. Basically what you do what is this feedback loop? It's basically trying to measuring something on the outcome of your service. And propagate that information back into the input so that you can act upon it, and that the system can self-heal, basically. One area where we do this is estimating tank capacities. So the fuel level that we get, it actually comes as percent. It doesn't come as gallons. So we get a value from 0 to 100. 100 meaning the tank is full, 0 meaning the tank is empty. But the transaction is gallons, right? So we need something to convert from percent to gallons, and which is obviously the tank capacity. We have a service that estimates the tank capacity gets the tank capacity from a third party, but for some, and specifically on mid-sized and big-sized vehicles, there's a lot of alternatives that you can even add more tanks to your vehicle. So we have a service that estimates that tank because we might get it wrong. And if we see that, for instance, that we are constantly, a certain vehicle is constantly being flagged to a certain amount, and we see that that's very consistent, we default to, let's check if this is a wrong tank capacity and re-estimate everything and see if that is true. If it is, if let's say the standard deviation of the estimates that we get decreases substantially, then we can say, okay, this was a wrong tank capacity, we're going to update it, and after that, everything should be fine. If we see that the standard deviation does not decrease, then we say, oh, okay, well, maybe this was not the wrong tank capacity, it's probably fraud. Yep.
I wonder if you can use this model to catch malfunction of an engine or things that go wrong with the car.
Yeah, absolutely. We also collect other features from the vehicle that also could help better indicate that. Rather than the fuel level, we have the engine temperature, for example. We have engine speed as RPMs. So there are definitely other features that we can collect that could be useful for other services like maintenance, for example. Not necessarily for fuel, but if we want to estimate that if a vehicle is going to need maintenance for some reason, like an oil change or something like that, maybe we can estimate it and predict it from other features of the vehicle. Currently, we're not doing that, but definitely now that we're going to enter into the maintenance world, I would believe that we will start doing it as well. Okay, so this was the part about reliability. The next one is scalability, and this is also a big part of designing data-intensive applications. You need to be able for the system to scale. So right now we are enduring into a new phase where all engineers are basically focusing on making sure that our system can scale to 1 million plus vehicles. That is a huge step, right? I mean, and I kid you not, this sometimes systems that work at 100K like rate, if you go to the million rate, everything breaks, right? So there are concepts and principles that you need to have in place when you are designing systems so that they can scale well. And it's important to have that in mind because sometimes you don't have the opportunity to rebuild the overall system. You might just tweak it some parts, but rebuilding everything is extremely expensive. So, and usually when you're at the startup level, when you're like just with a few clients, you don't really think about scaling because, I mean, you just want a product as soon as possible. But then, when scale comes, then you need to be ready to embrace it. So one of the things that you need to do for the system to scale is use concurrency. Concurrency enables you to divide the workload between different workers and let them, and again, control the number of workers that can do the work. So concurrency is definitely a big part of it. It also helps you to parallelize your system, meaning putting some components on some computers and some components on other computers, so that what it's usually called horizontal scaling. usually horizontal scaling is it's the de facto approach to achieve scaling. You can also do a vertical scaling, which is you have a single machine, you just make it more powerful. Usually, at least for our use case, that wouldn't work. Horizontal scaling is the one to go. Specifically when you have streaming data. If you have batch data, then you might scale well just with vertical scaling, but not if you have streaming data. Partitioning, sharding is also another big part of it to distribute the workload. Being able to not just optimize for the median, optimize for the high percentiles of traffic, so handling bursts of traffic, and performing testing under like high load conditions. In terms of maintainability, when you're designing long-term systems, code quality and the quality of your product needs to be there from day one. And that means building modular and decoupled components that can come together as an architecture. You define clean data contracts between these components because they're going to have to talk to each other, and data schemas. And if those schemas need to evolve, version your schemas so that if something goes wrong, you can always go back. So versioning is quite important. Automate your CI/CD pipelines. So when you're developing, so that you have the ability to continuously integrate your new features and deploy them into environments that are not impactful into production, like deploying into development environments and then staging environments and then eventually to production, so that you can test things in between. Document as well. I'm a big advocate that the code itself should be the documentation, should be the major documentation, which means, again, writing clean code is a big part of it in my view. This is some of the principles that I also embrace, and that's on a book called The Pragmatic Programmer that I try to embrace as much as I can. The first one, don't repeat yourself, meaning whenever you're repeating things, and when I'm saying things, it can be data. So for example, if you're repeating, like when I was talking about robustness and scalability, we're talking about replicating data. That's one thing that you do to create some robustness, but that comes with a drawback, which is whenever you're creating a duplication, you're creating room for inconsistencies. That's actually part of the gap theory that I was talking about. But you should, so I'm saying that you cannot necessarily completely avoid to repeat yourself, but you should try to. One place where you definitely should not duplicate things is in code. Don't have two functions that do the same thing. Refactor things and consolidate. Orthogonality, isolation, meaning try to make your components, try to make the components, whenever they touch to each other, to not affect their state so that they don't crash. So there's a certain level of isolation between your components so that nothing unexpected happens. The tracer bullets concept means start whenever you're building a project. Don't go through too much into the POC kind of phase, the proof of concept. Go as soon as possible to an MVP, to a product that you can actually show end to end, and make sure that it's as good as possible. So you can, and this helps you to validate the direction where you're going. Actually, even sometimes invalidate. You might say, okay, this product is not good. We're going to go back. But at least if it is good, and if you have buy-in from your management layer, at least you have already something that you can iterate upon it. And they can also, if they get excited with your product, then they can start working on, again, more on the marketing side, on the sales side, while you're still developing on top of your MVP. So this is a big one. Refactor continuously. Like you're constantly doing like a laundry kind of thing on your code. You're constantly throwing away things. Keep it clean. Keep it pristine. Treat it as almost like as a work of art, but the dynamic one that you keep working on top of it. Always update your dependencies. For example, if you have dependencies, the dependencies are going to evolve because I mean most likely you're not going to implement if you're doing machine learning. You're not going to implement your own scikit-learn just for the sake of controlling everything. But scikit-learn is going to evolve, so make sure that you evolve together. Also, communicate clearly. I spoke about this a little bit. Don't implement things that you don't need just for the sake that it's cool. That is also something that is quite pervasive around us engineers. There's always cool stuff, always cool new tools and new platforms, and sometimes we start chasing the little rabbits. Don't do it, or at least do it from a learning experience. That's definitely interesting, but don't take it too far. The last one is actually one that that's it's not on the book. It's from myself. I call it hidden dependencies. For the sake of everyone, I'm trying to be funny there. Keep it simple at scale. So what do I mean by that is try to eliminate, and it's funny because I thought about this one because I'm going through that process myself. Always step back, look at all the apps, all the libraries, everything that you implemented, and think, what can I remove? What can I actually throw away? And this is an exercise that sounds a little bit masochistic somehow. Believe me, it's the best thing. After you embrace it, every single time I can tell to my DevOps, say, oh, you can now kill this app. I don't need it anymore. It's a relief. Because when systems scale, managing all the complexity it goes exponential. So try to consolidate things, remove dependencies, go back to first principles, and that's pretty much it. Those are some books that I mentioned in this presentation. This was actually one question that I got like last time I was here, which books I think are important. Those ones impacted quite a lot, at least for what I spoke today. Thinking in systems, it's an old one, but I think it's amazing. It's one of my favorite books. The Pragmatic Programmer, also quite old, but they have a new version, the 20-year revised version. Also an excellent audiobook, by the way. Designing data-intensive applications already spoke on. For machine learning, my go-to is hands-on machine learning with scikit-learn and TensorFlow. I think it's a great book. It's less of a book that you would read page to page. The other ones are good. But as soon as, if I need to implement a machine learning model, the first thing, and I know that if it is, let's say, it's if it's a deep learning model or if it's whatever type of model it is, I go back to the chapter on that book and read it. And I've read several chapters of that book several times precisely because of that. I think it's a great one. Okay, so it's not about all about vehicles and payments at CarIQ. We're also a fun bunch to work with, and we try to keep to stay together as a team and have some fun. Our team is spread around the world, but we do have an office 10 minutes walking from here, and sometimes we do workshops where the other people around the world come and have some fun with us. But we try to keep things All right, and that's all I had for you guys. Thanks a lot.
All right, thank you so much, Eloi. That was really wonderful. Like I said,